Good afternoon. All right, so let's see. We've got is Joey on his way?
No, he's on an academic trip.
Okay. And we got Joran ditching as well today. How about Hannah?
She's just over at the job fair. She should be here any second.
Okay.
She better be.
Better be.
No, she should be on her way. I'm gonna go look and see real quick. And then
Okay.
but she'll be here.
All right. Unless she better. She's much later. She better come back with a job, right?
You got it. If anybody would get one, it would be her.
Oh, okay.
Okay.
All right. Well, let's. Okay, so today we're going to hopefully finish 8.5. We'll see how that goes. So anyway, I've got 8.6 up there too. I'm not sure if we'll get to it or not. But does anyone have any questions before we get started? Okay. All right. Well, when we left off yesterday, we were actually in the middle of this problem right here. And we actually ended up with, when we were solving for A and B, we got answers that weren't integer values. All right, so I think what I'm gonna do, because this is gonna help us as we get into the harder matrices, is I don't think yesterday I showed you how to do these on the calculator or remind you. So let's go ahead and do that for this one. We had worked this problem down to this system, and so I said that we would you put these in as matrices, the coefficient matrix. So 1, 1, 2, negative 3. And then you have your constant matrix. So 28, 25. So what I'm going to do is, like I say, show you or remind you. Actually, usually in college algebra, chapter 10 through MPC, we talk about how to put these in the calculator. So hopefully you've seen this before. If I can get the calculator to wake up. There we go. All right. So what we're looking at here is the matrix menu. All right. So what we're going to do is put in each of these matrices. So if I go to second and then X inverse, that's the matrix menu. So second matrix, and then I have names, math, edit. So what I'm going to do is edit each of these matrices. So the first one I'm going to call matrix A, and so I go over here to edit, matrix A, and the first thing you do is you tell it how big it is. So that's the dimensions of it are the rows by the columns. So this one is a 2 by 2. So 2, enter 2. And then you type in the numbers. So 1, 1, 2, negative 3. Okay? So everybody with me to that point, or do I need to wait up a minute? Okay? All right, then we'll enter in the constant matrix. So quit out of that matrix. Second quit, second matrix, and then we're going to edit, and we want to put this one in for matrix B. Okay, so this is a 2 by 1 matrix. So 2 by 1. And so 28 and 25. Okay, so now I have both of these matrices in my calculator. And so now to get it to solve it, I type A inverse B. So quit. So to get the matrix to come up, that's where the names, you get that from the names. So it's still in the matrix menu. So second matrix, and then the name, so A, and then inverse, and now B, second matrix, B, arrow down to B. And so A inverse B, and so that's going to give me my answers, and either you can have it come out as decimals or fractions. Okay. All right, so now, when you've got that worked out, okay, so by the way, this is showing you, I had somebody ask me, why do you type in A inverse B? Well, it's just like when you're solving a linear equation, like if I had 3x equals 6, then what I would do is divide each side by 3 or multiply by 1/3. And then 1/3 times 3 gives me the identity of 1. 1 times x is x. So the x, the solution, is the inverse of the matrix in front of it. So the inverse of A times B. And so then you would get x equals A inverse B. Okay. Let's go back to the problem. So then when we have our decimals or fractions, whichever way you have it, it really doesn't affect the answer too much because, so here are my A was 21.8 or 109 fifths. My B is 6.2 or 3 1/5. So when you put that up on top, then it's just the coefficient of the natural log. So your final answer is 109 fifths times the natural log of the absolute value of x minus 3 plus 31 fifths natural log of the absolute value of x plus 2 plus c. Okay, or, oh, and then remember when we started this whole problem with this with the division. So remember the first two terms were 4x plus 4. You integrate those and you get 2x squared plus 4x. So in your final answer, don't forget those. Okay? And I'm going to just rewrite the final answer if we wanted to do it in decimals. So that would be 2x squared plus 4x plus, let's see, that was 21.8, right? 21.8. Natural log of the absolute value of x minus 3 plus 6.2 times the natural log of x plus 2 plus c. Okay? So, any questions on that? Okay. So again, this all started doing our polynomial division. Oops. Okay, so now we're going to go to the next part. Integrating with an irreducible quadratic factor in the denominator. So now this is different because, see, when we have our linear factors like x minus p, then it's just, c over x minus p. But the quadratic factors, x squared minus r, it's actually ax plus b. So we're having two variables in that one term. So ax plus b because of the x squared here, and then each linear factor has a one letter, c over x minus p, d over x minus p squared, and so on. All right, any questions on that? Let's see if I can. All right. All right. So if you remember from yesterday, the first thing we do is factor the denominator. Okay? So let's start with that. All right, so Skylar, what does the denominator factor to?
Is it x squared plus 1 times x plus 1?
No, because see, your GCF is just x. So when you factor out an x, you're left with x squared plus 1. And see, x squared plus 1 doesn't break down any further because it's the sum of two perfect squares. If you had a minus in there, it would factor to conjugates. But that's what this one factors. So this is a linear factor, the x. The x squared plus 1, that's what we talk about an irreducible quadratic factor, in that it doesn't break down any further. Okay? So now when we set it up, see, it's going to be a over the linear factor, and then you'll have two letters, bx plus c over the quadratic factor. All right, so Chloe, what do I multiply the a by? Now we're in the next phase of it, trying to get common denominators and add those.
X squared plus 1.
And what do I multiply bx by plus c by?
X.
X. Okay, so go ahead and do that. And let's go ahead and keep going and then solve for a, b, and c. All right, so Aiden, when you've got A, B, and C, let us know.
Do you want us to do the matrices like you showed us on the calculator?
Whatever works, whatever you want to do. But I'll tell you what. Tell me when you get the system. Let's make sure you have the system right before you solve it. So tell me what you get for your system of equations.
Well, do you get 3x squared plus x plus 4 equals ax squared plus a plus bx squared plus cx?
Okay. All right, and then what? Tell me your equations then for your squared terms.
Ax squared plus bx squared equals 3x squared.
So that would mean what?
A plus b equals 3.
Right. So a plus b equals 3. All right, and then what? For your x terms.
Cx equals x.
So what does that mean?
C equals x. Or C equals 1.
So C equals 1. And then finally your constants.
A equals 4.
A equals 4. So with this system, see, it's simple enough I wouldn't waste your time putting it in the calculator. You can solve it here. So if A is 4, then you get 4 plus B equals 3. So B is equal to -1. Okay, so everybody cool with that? Okay, so now substitute back into the integrals. Substitute in the A, B, and C back to the beginning. All right, and now you should get this. All right, David, what's the integral of 4 over x dx? Okay, let me give you a hint. Pull the 4 out front. And what's the integral of dx over x?
It's natural log of absolute value of x.
There you go. So you'll have 4 natural log of the absolute value of x. Okay. All right, and let's see. Now let's pick on Hannah. What's the integral of, or how do I integrate? Whoops, I just kind of gave it away. How do I integrate this? Negative x plus 1 over x squared plus 1. There's an algebra trick here. Do you remember it?
I do not.
Anybody? See, the problem you have here is you can't do this by u substitution, because if you pick u to be x squared plus 1, the du would be 2x. So this 1 is messing us up. So when you try that and you think, oh, this constant's messing me up, then think, oh, wouldn't it be nice to separate it, to get rid of the constant? So that's the algebra trick here, is break it up to negative x over x squared plus 1 over x squared plus 1. Okay, so now the second one, now we can do by u substitution. Okay, so Hannah, do the u substitution on this. Well, everybody try it. Do the u substitution. Hannah, you tell us what you get when you get it. Now, how about the last one? Does anybody know how to integrate that one? 1 over x squared plus 1. Well, I'll just let you do the u substitution, and then we'll talk about it.
Okay, so I got negative 1/2 log natural of x squared plus 1.
All right, good. Good. So your u is this, your du, you need a 2 up there. So that's what you get, a 1/2, and it gets absorbed up there. So okay, good. All right, now how about the last one? Does anyone, this is a pattern. 1 or dx over x squared plus 1. That's actually a formula. Anyone remember what that formula was?
Was that the inverse tangent?
That is the inverse tangent, sir. Good job. So when it's, so the inverse tangent of x and then plus c. See, when you have the x squared plus a squared, it's going to be the inverse tangent when it's not under the radical. If it's under the radical, you have to use one of those triangles. Okay? But if it's not under the radical, it's going to be inverse tangent. All right? Good. Good, good. Okay, so any questions on that? Okay. All right. So the next part is a repeated irreducible quadratic factor. So x squared plus 1 doesn't factor and it's squared. So here we're going to have ax plus b over the irreducible quadratic factor to the first power, and then cx plus d to the quadratic factor to the second power. So again, it's because you can't factor it and it's quadratic, you're going to get 2 of them. All right, so let's just look at this setup here. We're actually not going to go through this. I just want you to see the setup. So here, when we're breaking it down, see the x is linear. So it's just a over x. But then x squared plus 1, that would give us bx plus c. And then to the second power, it'd be dx plus e. And so then you would go from there. All right, so let's actually go on to practice 5 though. Okay, so here I want you to just set it up. Just set up the 2 integrals when you break it down. Okay. All right, so Chloe, when you've got it.
Are you just doing the bottom part right now, the denominator?
Yeah, so I just want you to set up the A and the B and the C and the D and whatever. And then we'll do the bottom part. So I'm just asking you for the first step. So what's the first step?
What's the integral book?
The integral of ax plus b over 4x squared plus 1 plus the integral of cx plus d over 4x squared plus 1 squared.
Good. Okay. So any questions on that? All right, so Hannah, what do I multiply ax plus b by?
4x squared plus 1 squared.
No, just one. Just one 4x squared plus 1. Because we already have 1. So to get the common denominator, we just multiply by another one. Okay? And then what do we multiply cx plus d by?
4x squared plus 1.
Nope.
Oh yeah, nothing.
Nothing. Because it's already over the common denominator. Okay? All right, so go ahead and do that. And when you get your system of equations, Aiden, tell me what you get when you work all that out.
So I got 4ax cubed plus ax plus 4bx squared plus b plus cx plus d.
Okay? All right, so now how about the equations that you need for your system of equations? So when you break those down to the x squared, x cubed, x and constant, or what do you get?
Well, 4bx squared would equal 8x squared.
Okay. Actually, let's start with the x cubed. See, we have 4ax cubed equals, there's no x cubed over here. So what would that mean?
Would it just be equal to 0x cubed?
Right. So then what would that mean?
A is 0.
Yes. Very good. So 4a is equal to nothing, 0. So you can say if 4a equals 0, that means a is equal to 0. So that's kind of your first thing. All right, so that's for x cubed. Okay, so now let's do the one with x squared. So set the x squared terms equal to each other.
Is it still me?
Yep, yeah,
B is equal to 2.
right. So you get 4bx squared equals 8x squared. So if 4b equals 8, then that means b is equal to 2. All right, and now the x terms. Still you, Aiden. I'm going to let you finish this out.
Okay. So C is equal to 8
Okay, and how did you get that?
because it's AX plus CX equals 8X. But AX is just 0. So
Right, so if a plus c is 8 and a is 0, then you get c is equal to 8. Okay, good. All right, one more, the constants.
And it's just d equals 2.
All right, what about the b here?
I'll freak. D equals 0 then.
So, right. So b plus, so you write b plus d, the constants, equals 2. Okay, so b plus d is 2, but we already know that b is 2, so that means d is 0. Okay? All right, so now, any questions on that? Anyone having any trouble getting A, B, C, and D? So obviously, even though there's 4 of them there, we didn't have to put it in the calculator. So just sometimes you get lucky, sometimes you don't. All right, so now go ahead and substitute back up into the integrals what your A, B, C, and D is so that you can do the integrals. All right, so Aiden, still you. So what are the integrals going to be that you have to solve?
So it's going to be the integral of 2 over 4x squared plus 1 plus the integral of 8x over 4x squared plus 1 quantity squared.
Good. Okay, any questions on that? So just plugging in the A, B, C, and D. Okay. Whoops. All right, so Chloe, pick which one of these integrals you want to do.
I'll do the first one.
Okay, so you do the first one. Second one, well, everybody do both of them, but you tell us the answer to the first one. Hannah, you do the second one. So Chloe, when you're done, let us know.
I'm a little bit lost, but is it just 2x over 4x squared plus 1?
No.
Oh.
So listen, you guys, I'm really not trying to punish you here by beating you up with all these integrals. I'm really just the only reason I like this section is because even though it has too much algebra, I do like the fact that it helps us review doing the integrals. This is think of this as the u squared plus or x squared plus a squared. So when you have that as a pattern in your denominator and there's no radical, it's going to be inverse tangent. Okay? So this is the inverse tangent. So you let your u be 2x. And so then this is 2x squared plus 1 squared. And then see the du is 2 dx, which is exactly what we have. So this is going to be the inverse tangent of 2x. All right. So Hannah, how about the second one? Did you have any better luck?
I'm not really sure, but I got natural log of 4x squared plus 1 squared.
Natural log of 4x squared plus 1. No. No. And I'll tell you why. Because if it didn't have the squared here, then you would be right. Because, see, and I like how you're thinking. I mean, the derivative of this is this. So you would think natural log, but the squared messes you up. So what you do is you do this by u substitution. So you let the denominator be your u, and then your du now is the numerator. And so then that will become the integral of u to the minus 2 du, and then and so the integral of u to the minus 2 is negative u to the minus 1. So it's negative the negative of 4x squared plus 1 to the minus 1 plus c. Okay? So without that exponent, if it didn't have that exponent to the 2, you would be absolutely right. That's how you would go about it with the natural log. But when you have that exponent, then it's not du over u. It's du over u squared, which you do by the inverse power rule, anti-power rule. Okay? All right. Let's do some more. Okay, now the next method is actually a nice shortcut, okay? And it's so good, I wish that I could only teach it this way, the whole section. But the problem is the shortcut, which is called the Heaviside method, or sometimes the cover-up method, it only works for linear factors. So we could have done, let's see, the first 3 problems were linear, but once we started getting to the irreducible quadratics, this method doesn't work. So because it doesn't work for all things, then I have to teach the harder method, which is finding the A, B, and C that way. Okay? All right? So, but let me show you this. It's a pretty nice method. Okay? So this is the idea. Is that, okay, so let's say we're trying to find the A, B, and the C. And see, these are all linear factors. So what you do is you cover up, say, the one factor, the one over, say we're trying to find the A. So we cover up that factor. And then if it's, think of this as x minus r, we plug in the opposite of that number. So plug in 1 into here. So if we plug in 1, we get 1 squared plus 1, which is 2. 1 minus 2, negative 1 over negative times negative 2 is 2. So we get 2 over 2, which is 1. So A is 1. So using this method, you can pretty much find A, B, and C in your head. Or pretty close. So let's do it again. So let's say I want to find B now. So I cover up that factor and I plug in 2. So 2 squared is 4 plus 1 is 5 over 1 times negative 1. So negative 1. So 5 over negative 1, B is negative 5. Okay? Let's do it again for C. So here I'm going to cover up x minus 3. And I'm going to plug in what? What am I going to plug in?
3.
3. So I'd have 3 squared is 9 plus 1, 10 over 3 minus 1 is 2. 3 minus 2 is 1. So 2. So 10 divided by 2 is 5. So C is 5. Okay? All right, so see if you can. So on the next practice problem, so practice 6, what I'm asking you to do is just find A, B, and C. So we're not actually even going to finish it off. So just do this heavy side cover-up method and find
It's just A and B, right?
A and B. Yep, because you just have two factors here. So we're just going to find A and B. All right, so Chloe, when you've got A and B, let us know.
A is 23 over 5 and B is 7 over 5.
A is 23 over 5, B is 7 over 5. Excellent. Okay, any questions on that? Okay, good. All right, so integrating with the Heaviside method. So sometimes your A, B, and or C might be 0. We've actually had that happen before when we did solve for A, B, C, and D. But with this Heaviside method, you can still get 0 when you plug in. Okay? All right. So let's go ahead and do this. So let's see if you can do it the whole thing. Okay, so you start with your factoring, set it up, find A, B, and C, plug it in, and integrate. So see if you can do the whole thing on your own now. All right, so Skylar, let's take us through the setup. So what does the denominator factor to?
2x times x minus 2 times x plus 2.
Good. Okay. All right, so Hannah, what are A, B, and C?
Sorry, I just realized I did something wrong right at the beginning, so I'll have to fix that real quick.
Okay. Now, let me just say that, like, if you had your B and C over the different factors, that's okay. I mean,
Yeah, I know that. I just
Okay.
did the factoring wrong is all.
Oh, okay. All right, so while you're fixing it, let's see what David, can you tell me what A, B, and C are?
How would you figure out A? Again? Like, I don't know what number to plug in for.
Okay, so this is like 2x minus 0. So you plug in 0 to find A.
Okay.
To find B, you plug in -2, and to find C, you plug in +2. Okay, now we're running out of time, so I want you to finish this, and we'll go over the answer on Monday, and then try to finish this up. But try to have the rest of this problem done. Okay. All right. Well, you guys have a great weekend, and we'll see you. Be safe. And we'll see you on Monday.